Hi everyone, this is Rod Sidwell. In this video we're going to discuss activity 10-1, reading manometers. The drawings show various U-tube manometers set up to measure air pressure. The size of the manometer and type of manometer fluid change from drawing to drawing. Okay, so what we're going to want to do, measure the height from the lowest level of the working fluid up to the highest level of the working fluid. And to do that you might have to look at two different measurements. So this is the height we want right here. Okay, so problem one, what is the air pressure in inches water column being applied to manometer A? Well, here's manometer A here. We can see that it's 6.3 inches below zero here and 6.8 inches above zero here. So we're measuring differential pressure. Anything below zero is going to get added to anything above zero. So we'll just look at it like this. So basically all you do is take 6.3 from this side. And that makes sense because you're pushing down. And then on this side we're pushing it up. 6.3 plus 6.8 equals 13.1. Next one, what is the air pressure in inches water column applied to manometer B? Now this has specific gravity 1. We didn't have to worry about doing anything there. So does this one. Now this time it's the opposite case. The right hand leg is at a higher pressure than the left hand leg. So we have fluid here. Here's our zero. So this is pushing down more than this is pushing down as we measure the differential pressure across here. So now we're going to subtract this and we're going to subtract this. So let's see, we've got minus 4.1 minus 3.8, and that's going to give us minus 7.9 inches water column. So minus just means that this side's at a higher pressure than this side. So let's look at number 3. What is the air pressure applied in manometer C? Now we've got to pay attention because we've got this higher specific gravity fluid. So this really can have two parts. We can look at the pressure as the height times the specific gravity. And before, the specific gravity was 1, so that just didn't come into play at all. So first let's get the height part for number 3. And we're down 12.3 here, and we're up 12.4 here from 0, so 12.3, that's the plus part, plus 12.4. Both of these are adding to the pressure. So there's my working fluid. Here's my working fluid in here. This pressure is higher than this pressure. It's pushing this one down. The liquid's incompressible, so it flows up. So the total height that we're after is this height right here. That's the height we're always after. So you get 24.7 for the height. But now if we answer 24.7 inches of water column, that would be wrong because the fluid in here is not water. So we want to say the pressure equals H times specific gravity, and they tell us specific gravity equals 1.75. So 24.7 times 1.75. And we got 24.7 times 1.75, 43.2, we'll call it, inches of water column. So this is equivalent in pressure to 43.2 inches of water column. Okay, problem D. What we've got here is two fluids in there. We're working fluid, which has specific gravity 1.75, and we have some water on the top of this side over here. Alright, so first let's get this height. and that height's going to be equal to 9.7, because we're down 9.7 from 0 down to the working fluid. So that's 9.7 there, plus from 0 up here to 10.1. So we've got 19.8 inches of working fluid, and the pressure that that generates is equal to H times the specific gravity. That's equal to 19.8 times 1.75. Now we just have to subtract off what the water does. Now if it's on this side, if I have excess fluid on this side, I subtract it away. If I have excess fluid on this side, I add it. So we've got to find this little height here, and it's going to work out to be 9.7 inches, because that's the distance down to the working fluid, up to 8.3 inches. That's 0.6 inches, and it's water, so we're going to subtract that away. So the pressure is going to be equal to 19.8 times 1.75 minus 0.6 times 1. And if I look at this, I've got 19.8 times 1.75, 34.65, and if I subtract off 0.6 from that, 34.05. Okay, so let's look at number 5. And 5 is seemingly hard, but because we have two fluids, we have water on the top of this side and we also have water on top of this side. So same as before, we're basically going to add 3 pressures. So the pressure from the working fluid plus the pressure on the water on the left side plus pressure on the water on the right side, and this one's going to end up being negative, that one's going to end up being positive. So let's finish drawing our manometer here. So just like before, here's our working fluid. We're going to find H of the working fluid, and we're down 6.5 on this side and we're up 6.5 on this side. So that's 13, equals 13. Now the specific gravity is equal to 2.95. So we can just do this whole thing all at once. We got 13 times 2.95. Now we got to subtract off this little bit of water over here. Now specific gravity of 1. You see it's 6.5 inches and then 5.5 inches, so that's 1 inch times 1. Then we got to add, you know what, it takes a little extra pressure to lift that water that's on top of here, so we add that on, and that's going to be 6.9 minus 6.5, that's 0.4. That has a specific gravity of 1. So these two add together, end up subtracting. So we'll just go ahead and do it on the calculator here. So we got 13 times 2.95. So there's the working fluid without any correction, minus 1 plus 0.4 equals 37.75. And what you can see here is that we could even solve this for the general case, because really what this is just a bunch of pressures added together. So we got the height times specific gravity, the working fluid, minus the height times specific gravity of the fluid that's on the left hand side, plus the height times specific gravity of the fluid that's on the right hand side. So these are our adjustment terms, and then that's the working fluid. Okay, that wraps up 10-1. Have a great day.